Okay, so I feel like I keep rehashing the same statement, but this video will actually do it, okay? So here's our robot model, and actually I was thinking about this today. Once it has like a map plotted and it's like, alright, I can go straight for 30 inches or whatever, the sensor and camera will be in a neutral position, like looking straight ahead, and it will actually sample, the world as it's moving forward to make sure, like, if you stepped in front of it or like my cat gets in front of it, it stops moving, and then once it's clear again, it would continue to move. So that would be a nice little capability there. But I want to talk about this again because this is like the beginning of the video. So you would consider like this square here to be safe. So you start building those up in the world, and that's how you'd start producing the map. Which, if you imagine, say you got like red is like a wall, right? So you like this, and then there's like a area over there, this, that, and then this is your robot. So we're actually gonna do like path planning, where it's like, oh, okay, I can go all the way over there, I can go over here, and that will involve collision detection, like a video game. If this boundary crosses over there, so that's what we'll be doing next. So I've been thinking about how to make this map in 2D in the memory of the Raspberry Pi. Like, this is the world that the robot will create as it scans and moves around. So I've shown this shape before where the scan pattern, the full scan pattern, produces this, and then depending on the error, it's like an inch off. So if something's there, there's an obstacle, and you may end up cutting off, like this. And if something's there, I wouldn't even bother with the back scans. I would just assume they're bad, and I would only have like this half, well, maybe including that front piece. But anyway, so yeah, so in order to do that, we've got coordinates. So if you have an axis, here's a square. Thinking about graphing here. This point right here, you could say that's 1, 1. Oh my god, the lag. I'm recording the screen and the cursor is slow. So that's 1, 1, and then say that's 3, 1, 5, 1, or no, 5, 3, 1, 3, It's just a basic coordinate system, a grid. So, and then in SketchUp, you can easily like do this where these are inches. See, like 3 inches. You rotate this 90 degrees, this square or rectangle here, and then here's that same edge. So you're trying to do that in Python, and I have done that. Using Matplotlib is just for visualizing. You end up being able to create this, but this is just for visualization. Damn, it's raining hard, so a lot of accidents. This is just visualizing the state of the robot, the world state, the map. So yeah, what I did is, this is a new So we've got our like navigation folder. So we've got a map folder. What did I change here? Oh yeah. And then this class, this map class, the scans. So the way I decided to store a scan plane, it's based on this coordinate system, right? Like X, Y. And this point right here is the X and Y offset. That's what this corner is. And then this edge is the width, and that is the height or distance. I called it distance because it's the ground. So that's what we have here. Like the angle is rotation angle. You can see in the drawing here that like this robot's gonna turn, and it's not gonna be like, you know, it can be diagonal, yeah. Although the scan pattern is designed to move in 90 degrees, but yeah. Anyway, so that's what that angle is. Get X and Y offset, the width, the distance, and then time is just logging elapsed time when the scan was taken. And then I just looked up, you know, on Stack Overflow to do some of this stuff. So this plot here, you're setting the boundaries. That's what the -10, 10 is. And then so here's an example. You call scan plane. It's using this, it's like a struct equivalent, but in Python, this data class annotator. So you put in the angle, this is the X and Y offset, this is the width and the distance, and then no time yet, but you would just call, you know, time.time there. And really I'd only be interested in the first part. I could just go with integer, number, dang, int, there. But anyway, yeah, and in the case I did is 90 degrees, so we're using polygons to plot, and this add patch. But yeah, this is all like a visual thing. The polygons will all be stored, you know, in like an array like this, and then you would iterate over them where the robot, its current coordinate and dimensions, if it overlaps anything. Anything that is a solid object, which or is not open. But yeah, having a visualization mechanism like this is good, because then you can see the robot's state. And then you can translate this to ThreeJS as well. But yeah, so that's where I'm at here. I still have to actually like connect it to the robot and start figuring out how it's going to build the map. And then the path planning. So yeah. And then you can see over here I just have like a test file, because I'm running this on my Windows computer, and it's not pulling up all the sensors and all the hardware that's tied to the Raspberry Pi. So that's just over here. This is the code the Raspberry Pi calls. Yep, that's what I've been working on. And then these are getting the vertices from the plane, and you use rotation math, like cosine sine, to get the rotated values. That's how you go from here to here. Alright, let me do a quick recap of what I've done so far. The goal I wanted to do was plot a scan. This is a portion of a full floor scan. You can see I achieved that with Matplotlib. That's Python. This is, I mentioned before, this is not used for the actual navigation of the robot. This is just for the human to do like a simulation without turning the robot on, and just to like see things. The other visual aspect will be the ThreeJS, because these things will be plotted here, and then there will be like a 2-map toggle where one is like a robot view like this, and the other one is just a 2D map thing. I still have to work on that, but yeah, so I just wanted to go over what I did recently. So I went through the data again. These are flat floor scans to figure out the min-max and errors. You can see the wooden floor scans are really bad. Like 319 is a maximum infinity value. So the angle is so shallow, like this is 15 degrees below the horizon, pointing at the ground, that it just bounces off the floor. Like it just skips off it and doesn't come back. So I decided I'm not going to include those, but you can see what I was trying to do is like figure out the min-max for all these values, like between this one, this one, this one, this one. So like in that case, 913 would be the lowest, right here, min 955, and then the error is like the difference, the largest and smallest, which I ended up just rounding that up to whole numbers. You can see too how when you just do these two, the errors go down. Like this is usually 1 if you include the wooden floor. So that made me cap the scan. I'm not going to use the 15-degree one just because it's so inaccurate. It sucks because that means the robot can only go forward and scan like 10 degrees at a time. But it does speed the robot up, and ideally you'd combine the depth scanning with an image from the photo or the camera, but I don't have that yet. Anyway, so we've got that, and then next I'll have to actually like plot this 360, and I think I'm just gonna switch to using ThreeJS at this point, because aside from doing the math in the code, which I'll go over real quick what I have so far, you're mostly going to be interacting with this UI, so I think it's time to start putting work into this. I want like telemetry to come in here, like what the robot is deciding, doing, and then there'll be like an error alert if it's stuck. But yeah, so let's look at the code real quick. So navigation here, I just disabled the third set of data, and when it does the floor scanning it won't have that set, so it'll be faster. This command is just to I think to do the rotation. Yeah, rotate 90 degrees. That's not relevant. Let's see. I got this tiny keyboard. Alright, there we go. So the scan floor planes, how do you say it? Full scan floor planes. I've got them predefined, so whenever you do a scan, it can just plot them and you offset it. Oh man, I should put that in actually. Yeah, we want to put down angle offset here. These are all based on a 0, 0 axis. And to briefly explain that, so like here, this is XY, think of like a chart, or it's XZ because Y is vertical, but yeah. So the charts are plotted with regard to that, like when the robot moves forward and turns, those are the offsets, like from the 0, 0. 0, 0 is like where the robot was initially turned on. So those will come in, we'll put in offset X, offset Y. That'll come in right here. These values are defined right here, this struct, X offset, Y offset, and then the width and the distance is, you know, this. I explained that before. I'll have to fix this chart actually after making this update. Yeah, so that's what I'm going to work on next. Is the robot will do the scans, and then we'll see a full chart. And I think I'll just do it in ThreeJS. So let me do that. I just took that, and you can see here when the map is instantiated, it calls this, which calls the method here, and then it adds those as lookups. So the this loop here can add them to the plot, which again, this isn't how the robot's going to work. This is just for me, or the human, to look at and simulate stuff. But as it runs through this navigation code, it will use the map to log the scans. But the data will get transmitted to the UI, and it'll do the navigation in the navigation code, but the human will know what's going on because the data will be mirrored here. Okay, so there's quite a bit to go over. I wish I was more structured, but I'm like really spent. It's like 12 hours of a day working on this, with some breaks in between, but yeah. So you can see there's 2 buttons now, and also this telemetry has data being shown. If you click this, you're switching between this robot view and then this map view. This one you can't rotate, but you can pan it. It's intended to just be a 2-dimensional. These are 2 separate ThreeJS instances, so I'm just hiding them with CSS. And you can see this isn't connected, but you know, if it was, you can start the navigation process by hitting start and hitting send. And then the map, it plots scan planes, which I decided, or I reworked it. You know, I replotted all the beams and then chose like the shortest ones per side, and I overlapped them. Like I had a right side and a left side. I flipped them over. Now we have this as a half, and over there you can see like a 90-degree rotated like 360. And then it moves forward by 8 inches because that's the length of these scan planes, the distance. So yeah, and in this video I show at some point that's what it's doing. Like it plotted the overlaps and then it moves forward. So look at the code, which there's a lot, unfortunately, but I want to explain it. Okay, let's get this in the view. I don't need this. So, Raspberry Pi side, the navigation, I updated this because, not navigation. Let's start with main. I put this in a class because of a circular dependency problem. Like the navigation needed the socket server and vice versa, so by having a reference to itself, this self here, then they're able to use each other. Hard to explain, but yeah, well, where is it? Oh yeah, right here. See this socket server? I'm passing self down into it, which is referencing this class. So if you look at socket server, it takes in main and it has a reference to main. So when it has to call navigation, it calls it through this. This is how the interface start triggers the navigation process. So if you look at the navigation file, I had to set the min-max values. So when it scans the floor, it checks if the sensor depth that's measured is above or at this minimum value and below or at this max value. And yeah, it took me a bit to manually set those because, you know, I did those averages before, but then I'd run them on the floor, and somehow that's the thing that's annoying about these sensors. Like, they're cheap, you know, so you have to have like a huge margin of error. These are like whole inches, you know. But anyway, so if you go down here, this is like a thread. This is that navigation start call. Then it comes down here. This is where it's not a true self-navigating thing yet, because I have to come up with an algorithm based on those like scan planes, like go this way, that fails, go that way kind of thing. But we have the basics of the full workflow with the ThreeJS, but the onboard navigation part still needs work. I'm mostly focused on bridging the web interface to this. But anyway, and messaging and whatnot, like telemetry. But yeah, so when you call start, this first scan, the first scan is because when you drop the robot in the world, it has to like scan 360 and see what its environment is like, and then it can decide which way to go. And this is just programmed, for the video, but so it does the full scan, which is just a basic loop going 90 degrees at a time. And this is like some new stuff here, like this send client message that's going to the web, and it's sending telemetry, which those pop up here, and in the video you can see them coming in like receive scan data, and that's plotting telemetry. It's not sending the actual values because those are hard coded, like the floor is either clear or not, so it already knows like the size of the plot to plot. It's really just visual, and the actual like navigation would happen on the robot side. But anyway, yeah, and then these are like values I figured out with a tape measure. So yeah, and this is like the structure of sending the data. When the robot moves, like for example, this move forward 8, it's incrementing the y offset. Wherever you set the robot down in the real world, that's the 0, 0 coordinate. And also you factor in the angle, which we have like rotation commands and whatnot to, that's how it's, plotting 90-degree planes. But anyway, and this is like the scan clear, like if this is false, the scan is red. But so we'll trace from here to the web client. So we go to the web client. I mentioned there's 2 canvases, you can see that here. Those are just toggled with a CSS class. And then the scripts, I cleaned it up a little bit because there's a couple that weren't being used. But anyway, so here's like the socket part. This is that connecting message, like connecting to robot. You can see it showing up here. And when it actually connects, then this like turns green and starts receiving stuff, and you can command it through here. But anyway, so we add the parser. It takes in the JSON data. It's like scan data or telemetry. That's just like updates. And then we go to now you'll see there's 2 different ThreeJS's, and this code is like really trash. It's from when I first was working with ThreeJS with the twerk ladder robot. That was like 2 years ago. But I got something that worked. But yeah, so this one's a little better, but it's still trash. It's just random stuff. But so the very basics of the map is here to render the view. That's just like the grid that you can pan. So that starts up. Can read through this code, but yeah, and this is like that hiding toggle. And the disable rotation part is like right here, enable rotate false. So we get the command, actually let's go back to the socket, like right here, plot full scan plane. So you go to plot full scan plane, it pulls this information out of that data that came from navigation, this stuff right here. So that comes in full scan planes, and the plane has 4 parts, like so it plots the closest right, farthest right, and then closest left, farthest left. I skipped the out of the 3rd layer because it's so bad. So yeah, that's what's happening here. It's plotting 4 of them. And then you can see the red blue if there's an obstacle detected. This I'm using Z4. That's just because the I was thinking it's kind of confusing about this robot. Like the wheel is back here, but the center of the robot is this IMU, which is back here. And actually, what I'm considering center or 0 is this IMU, which technically is wrong because it's offset. But yeah, there's a lot of things to consider, but this thing is crude. It's just like basics. So yeah, there's that offset, and then the Y offset that happens on navigation. See, it's stored here. That gets sent over here as well. These are the like scan values. See, like 10. If you measure right here, 10. That's where that comes from. Oh, you can't see it. Oh no. Oh no. Oh no. Wait. 10. There you go. So that's what these values are from. They're plotting the planes. You can see here I was like testing before I had the full flow working. Actually, I'll just take those off. I don't need the single plane because that's functional already somewhere. So yeah, plane vertices, that's the same as in the Python side, but it's JavaScript. Rotate plane. So yeah, referring back to this video, like you see we've got the plotting, you know, front one, go 90. Wait, what happened? Oh, that's the wrong side. Damn. It should be over there. Okay, I'll have to fix that. There. Interesting. That could be a axis thing. With my rotation code, I treated counterclockwise as positive. That's like a common convention, so I'll have to double check that. But yeah, anyway, you can see it's, you know, doing that, and this gap doesn't matter because like that's inside the robot, so it's got to be clear. And yeah, move forward. So this robot is going to do that, and it's a time-consuming process. Like this thing you can see in this video, it's like 2 minutes long to do this process. Well, it finishes there at 1:15, and then it moves forward. So yeah, it's going to take a while to build like a map, but this actually is going to get moved to the 3D robot view, and this view here will be just like a clean map. It's not going to have the overlaid mesh or overlaid planes. So that's what I've got right now. More work to come.